So in this problem, they're asking us to find the equation for the corresponding problem. So the key information that we have right here is that the period is 1 second, and we know that the period of either sine or cosine is 2 pi over b. So we can say that 1 equals to 2 pi over b. And if we solve for b, we have that b equals to 2 pi. So that hasn't changed. And the next thing that we want to know, and it already tells us that the amplitude, or A, equals to 14. Now here, if you're thinking, when do you use cosine, when do you use sine? I did a little sketch here on the right hand side to for sine and cosine. So we want to be able to use the sine function, because the sine functions, we have that it starts at the 0 position, like at the origin, right? So it hasn't moved. While the cosine function is already like shifted up. So when you say that something, you have something that is at sea level or something like that, or at time, the time equal to 0, its initial displacement, we'll use the sine function. If we say maybe we have stretched something, or something has been starts on a different position, then we'll use the cosine function. So this one, we'll use the sine function, because we have right here at sea level at time t equal to 0 seconds. And since it moves downwards, it means that the sine function is moving downwards, so we would have a negative sine function. So all I would have right here is y equals to the negative 14 sine of 2 pi x. And this is the equation. Actually, in this case, we won't have x, we have time, because it's with respect to time. So this will be our equation.